Google PaLM API is absolutely free alternative to OpenAI. You can build powerful applications using PaLM API for free. And it comes with its own embedding model as well. That means you can develop information retrieval system using PaLM API and many other applications as well. In this video, I will show you how to access PaLM API and use this in Python. Google PaLM API is available as a part of Google Maker Suite. So let me show you how you can get your own API key. So I will just go over here. So I will just click on get your API key. So to get the API key, you need to request for the access. So after you request for the access of the API key, you will get the you will have the access to the API key within 6 to 7 hours. So you can just create a API key in new project from here, or you can create API key in existing project as well. So it will not generate API key. So this will take few seconds. So now you can see over here, API key is generated. So you can just copy this. Over here, you can see that I've just created 3 different API keys. So you can use a single API key in your different projects as well. So let us use this API key and let's write some Python code. Okay, so now over here, you can see I have just created a notebook file over here. And in this notebook file, I will show you a text summarization example as well. We will provide some input text, and using PaLM API, we will generate a summary of that text. Okay, so first of all, you just need to install Google Generative AI package. So by just running this cell, you will be able to install the Google Generative AI package. So this might take few seconds before it's done. Now the package is installed. Google Generative AI package. Now we'll import the required library PaLM from Google Generative AI. Then over here, I will just pass my own API key. You can just pass your own API key after generating the API key from developers Google. So here I've just passed my own API key. So now Google PaLM API consists of different models. But in this example, I am concerned with that text generation model. So here I will just write generate text model. So I'm just concerned with the text generation model, and this will provide me all the models that are available in Google PaLM API, which are text generation models. So it will give me the text generation model that from the list of models that are available under Google PaLM API. So over here, so now you can see that this is the text generation model that is available under Google PaLM API. So you can see that this is the only text generation model. Text Biscon 001 is the only text generation model that is available under Google PaLM API. So I will be using this text Biscon 001 model. The input, it has an input token limit of 8096 token, and the output token limit is 1024 tokens. So you can just check more details on the Google PaLM website. So I've just saved the model name in this model variable over here. And over here, I've just passed the input prompt over here. So you can see that here I'm just using few short prompts. So I've just written over here, provide a summary of this paragraph by including all necessary information. So this is the text over here. You can see this is a summary of this text. So this is a text and this is a summary of this text. So here we have around 164 words and the summary has 94 words. So you can see that this here we have 164 words and in the summary we have 94 words. So this is an example text and this is the example summary. And over here we have the text. The COVID-19 pandemic is necessitated a global shift to online learning, while researchers have examined the impact of remote learning. So we are just providing this text and let's see whether we are able to generate the summary of this text or not. So here you can see that I'm just generating the summary of that text. So here I'm just passed my model in as the input. So here model name, this is, and here I've just passed the prompt, set the temperature value to 0.3. The temperature value varies from 0 to 1. Okay, so if you are generating some code, then you can set the temperature value high. Like if you set the temperature value high, it will generate a very concise response. So if the temperature value is low, so it means it will take bets. It might generate raw response, but it will be very creative. So here we are just creating some text, so we can keep the temperature very low. And the maximum number of output token is 800. So 800 tokens means we in one token we have 4 English characters. So our output will have maximum 3200 English characters. So you can just vary this as well. And here we have the summary. Now, if I just run this, so the COVID-19 pandemic forced a global shift to online learning. This study explored elementary teachers' perceptions of teaching online during the pandemic. So I've just checked this. This text contains 189 words, and in the summary we get 39 words. So we have got a concise summary, and here I've just shown you a text summarization example using Google PaLM API. In this video, we will learn how we can create a chatbot to chat with multiple PDFs documents using PaLM 2 as our large language model, Pinecone as our vector database, and LangChain, which works as a framework to build large language models. Before we discuss the architecture, let me just give you a short preview about Google PaLM API, which we will be using in this project. So Google PaLM API is absolutely free alternative to OpenAI. You can build powerful applications using PaLM API for free, and it comes with its own embedding model as well. So Google PaLM API comes with its own embedding model as well, like OpenAI. OpenAI also provides embedding model as well, but OpenAI has a cost associated, while Google PaLM API is free and its embedding model is free as well. And you can build information retrieval system and many other applications using PaLM API as well. So Google PaLM API is available as a part of the Google Maker suite. So I will show you as well how you can get your own API key as well. So let's get started. So first of all, this is the complete architecture. Let me explain you step by step. So in the first step, the user uploads multiple PDF files. You can upload 3, 4, 5, 10 PDF files as well. So we cannot, in the next step, the step number 1, the user uploads the PDF files. In the step number 2, we will extract the data from those PDF files. So we will be extracting all the data content that is inside this PDF file. So after extracting the data, we cannot pass the data directly to our Google PaLM 2 model, because the Google PaLM 2 model has an input token limit, like it has an input token limit of 8,196 tokens. So it means that it has an input token limit of 32,000 English characters, because 8,196 tokens mean one token is equal to 4 English characters. So we can pass maximum 32,000 English characters maximum at the input of PaLM 2 model. So if we have tens of PDFs file and we extract the data from those PDF files, so after extracting the data, that can be more than 32,000 English characters. So we have tens of PDF files and we extract the data from those PDF files. So it can be more than 32,000 English characters. So we cannot pass that data directly to our large language model, the PaLM 2 model. So what we do is we split the data into small text chunks. So we create text chunk and we define a limit, like each text chunk will have maximum 800 English characters or 1000 English characters. Then we create embeddings for each of the text chunks. So if we have 10 text chunks, for example, then we will create embedding for each of the text chunk, and then we will have 10 embedding vectors as well. So what we do in embedding is basically used to compress the size of the text chunk. So embedding are basically used to compress the size of the text chunks. So if we have 10 text chunks, then we will have 10 embedding vectors as well. And this is how embedding look like. Embeddings are basically list of floating point numbers. So you can say that embedding is basically a list of floating point number, and you can say that 0.1, 0.3, 0.3. This is the form of embeddings which we have. Okay, embeddings are basically vector stores, okay, that contain floating point numbers. So for each text chunk, we will create embeddings. So embedding basically used to compress the size of the text chunk. Then using all those embeddings which we have, we will build a semantic index. And after building the semantic index, we will create a knowledge base. In the knowledge base, we will store all these embeddings. Okay. So we will build a vector database or vector store where I will store all the embeddings. So if we have 10 embeddings, we will store all those embeddings in the knowledge base or vector database. So we have different vector databases available as well. So we have FISE, Facebook AI Similarity Search as a vector database. We have a Chroma DB as our vector database. So Chroma and FISE store the embeddings locally in our system. So, okay, so Chroma and FISE vector store the embeddings locally in our system. While in this tutorial, I will be using Pinecone as our vector database. Pinecone store the embeddings in the cloud and anyone can access those embeddings. So if you just use FISE or Chroma, they will store the embeddings locally and uh, everyone cannot access those embeddings because it will be saved locally in your system. But Pinecone save the embeddings in the cloud and anyone can access those embeddings by using the index name. So we will be using Pinecone. So Pinecone saves the embeddings in the cloud and anyone can access those embeddings. Okay. So if the user asks a question, so what will happen? When the user asks the question, we will create embeddings for those questions, which can be in this form. Then we do a semantic search. Okay, so after creating embeddings for this question, then we'll do a semantic search. We'll try to find top 4 answers for this question the user have asked in our knowledge base. So if the user has asked a question that we have for the question that we have solution in our knowledge base. So if the user has asked a question from any of the PDF that we have uploaded and we have extracted the data and converted into text chunks. So if the user asks a question from any of the PDF, then we'll look for the answer in the knowledge base and we will find 4 to 5 relevant answers for that question from our knowledge base. Okay, so we will just rank top 4 answers that we get for that question in our knowledge base. Okay, then we will rank those answers like this is the closest, this is the most closest answer to this question. This is the second most closest answer to this question. This is the third most closest answer to this question. Then we'll send those responses or answers to our PaLM2 model. And PaLM2 model will take the question directly as well. And it will take the responses over from here as well. And using PaLM2, we will generate a natural response. So this is a complete architecture of how it works. Let's move towards the implementation part. So you can just select the GPU as well, or you can simply use CPU as well. It all depends on your choice because we will be using a PaLM2 model through API and it's your choice whether you use GPU or CPU. So we will just install all the required packages first. So this might take a few seconds for these packages to get installed. So we are using LangChain package. So LangChain works as a framework that allows us to build large language models. Then we have Pinecone because we are saving our embeddings in the cloud. So we require Pinecone because Pinecone is works as our vector database and help us to store the embeddings in the cloud. Then we have PyPDF package. So using PyPDF package, we will load the PDF file and extract the data from those PDF files. Then we have Google Generative AI. So we will be using this package so that we can download embedding models or we can use embedding model of Google PaLM2. Okay, so you access the Google PaLM2 embedding model. So we can use Google Generative AI package. So why we need embedding model? Because we want to create embeddings for each of the text chunks. So to create embeddings for each of the text chunks, we need the embedding model to download the embeddings. Okay, so now we will import all the required libraries over here. So we are using PyPDF directory loader so that user can upload a PDF file and we can extract the data from those PDF files. Then we have recursive character text splitter so that we can split the text into small chunks using recursive character text splitter. So you can see that here we have split the text into small chunks. So we will be using recursive character splitter, text splitter to split the data into text chunk. Then we use Google PaLM embedding so that we will create embeddings for each of the text chunk. Then we have Google PaLM model so that we can do a question answer using PaLM model, Google PaLM model, and Google PaLM model will generate a natural response. Then we have Pinecone. Pinecone is our vector database. We will store our embeddings. Pinecone works as a cloud vector database. Then we have retrieval QA so that, for example, we are doing information retrieval. When the user asks a question, we retrieve the information from the PDF files. Then we have prompt template. We will define a custom prompt template as well. Then we have Pinecone again because we are storing our embedding in a cloud database. Then we have import OS so that we can define our Google PaLM2 API key. Then we have import sys so that we can exist from the chat. So now we will just create a folder by the name PDFs over here. So now you can see PDF folder over here. So inside this PDF folder, currently it's empty. We will download those PDFs. So I've already uploaded these PDFs in my Google Drive and I have added links over here. So I'm directly downloading those PDFs from Google Drive into this PDFs folder. So into this my Google Colab notebook. So I'm directly downloading those PDFs from the Google Drive into that Google Colab notebook. So you can see that I have just downloaded this PDFs over here. So let me just show you how it works. So I just open them over here. So this is the first PDF file. So you can see that this is a paper on YOLO V7 object detection model. So you can see that this is a 15-page long paper. And we have a second PDF file about this is an AI generated resume of Rachel Green. And you can see that here we have its qualification, teaching experience, and we have its publications, different awards, which she has obtained during her professional career. Okay, so now we will extract the data from those PDF files. You can upload tens of PDF files as well, like 7, 8, 9, 10, 15, it's all your choice. So we will extract the data from those PDF file and the data will be saved in the variable data. Okay. So now here we are using loading those PDF files and extracting the data from those PDF files. So you can see that we have extracted all the data from those PDF files. So this is a long data. Okay. So if you want to see the data more clearly, you can just try it over here. So you can see that this is the data which we have extracted from those PDF files, and it starts with from here. YOLO V7 trainable bag of freebies, new state of the art for real-time detection. This is the name of the paper, and it goes and it ends with Rachel Green resume. It should end with Rachel Green resume. Okay, so now you can see that this is ending with Rachel Green resume, and you can see associate professor of English. And here we can see the qualification of Rachel Green. So that's so good. So this is taking quite much space. So now after we have extracted all the data from those PDFs, we will split the data into small text chunks. Okay. So now we will just use the recursive character text splitter, and each text chunk will have maximum 500 English characters, and there will be an overlap of 20 English characters. Okay. So now you can see over here, and let me see how many text chunks we have. So we have 168 text chunks. So now you can see that we have extracted the data from those PDF file and split the data into small text chunks. And we have total 168 text chunks. Okay. So now we will create embeddings for each of the text chunk. And over here, I've just passed my Google API key. So you can just go to right over here, Google PaLM API. And you can just go over here. Okay, and then you can just go to Google, go to MakerSuite. So Google PaLM API is available under Google MakerSuite over here. And you can just write over here, create an API key, create an API key for a new project. So you can see over here, you can just create an API key for a new project as well, or you can just use existing API key. So we have just created multiple API keys over here. So I can just copy this, and you can get your own API key as well. For this, you have to first submit a request, and within 7 hours, you will get access to your API key as well. So I just ask you that needs to submit a request to get the API key, and within 7 hours, you will have the access to API key. So it's very simple. And here I will just add my API key over here. So now I will just using Google PaLM embedding. So I told you Google PaLM comes with its own embedding model as well. And you will using Google PaLM embedding model over here. So it says that I have not installed this package. Okay. So let's install this package over here as well. So now I will just run this cell. So we are just downloading embeddings from Google PaLM embeddings, and those embeddings are saved in the variable Google PaLM embeddings. So now let me just check the length of those embeddings. So the length is 768. So I will just go to Pinecone from here. So you can just get a paid subscription from Pinecone. It allows us to build to have multiple vector database inside the Pinecone. So I don't have a paid subscription on Pinecone. So I can only create one vector database. Okay. So with the paid subscription, you can create multiple vector databases. So I've already created one. So I will just delete this and create a new index over here. So you can just create index. Okay, so now you can see that our length is 768 over here. Just copy this and add here and just create an index over here. So currently it's initializing. So this might take 2 to 3 minutes to get ready. So, okay, so here I've just passed my Pinecone API key. So you can just get your API key from here. This is your API key. Okay, and this is your name of environment. Okay, so just you need to pass the Pinecone API key, Pinecone API environment over here. Okay, and let's go to the indexing. It's initializing. So as it gets ready, then you will just go ahead. Okay. So let's wait until it's get ready. And you can see the green signal. It's mean it's ready. And you can see the dimension 768 over here. And my region is Asia. So if you are living in US or Europe, so your environment over here, the region will be different as well. Okay, so I'm just using a free index, free tier over here. And you can see that it's monthly cost 0, but I can just only create one index. So you can just get a paid subscription from Pinecone as well. And you can just create multiple indexes. And it will just store my database vector. So it will store my data for 1 week. Okay, because it's a free index. So if you have a paid subscription, then it can store the data for a longer period of time and it will not be deleted as well. Okay, and plus make sure that your dimension is 768, which you can find over here. This is the dimension of your embedding model as well. So now I'm just passing my API key and just setting up the environment over here. And here I'm just passing my index name. So you can see your index name over here. So this is the index name. So you just need to copy this from here and add this index name over here as well. So let's run this as well. So now I'm just creating embedding for each of the text chunk. So over here, what I'm doing is that I'm just going through each of the text chunks and just creating embeddings for each of the text chunk. So what we are doing here is that we are just creating embedding for each of the text chunk. This is the steps which is being performed over here. So over here, I'm just creating, I'm just initialize index over here and just saving my embeddings into this Pinecone clouds. Okay, so I'm just saving those embeddings in a Pinecone vector database. So what's over happening over is that we are creating embedding for each of the text chunk, and then we are just saving our embeddings into a Pinecone vector database. So our embeddings will be saved into this index over here. Okay, so if you have already saved your embeddings in a Pinecone vector database, so then you can just call this cell, because currently we are saving our embeddings in a Pinecone vector database. So I will not call this cell currently, but if you have already saved your embeddings in a Pinecone cloud vector database, then you will just need to run this cell. Or you can see that the cell has run successfully. And you can see over here, we have saved our embeddings over here in Pinecone, our index. So now you can see over here, we have saved all those embeddings into this index, and you can see over here, it goes from 1 to 50 pages. That's good. And in each page, we have 10 rows and it goes up to 50 rows. Okay. So it goes up to 50 rows and in each page, we have 10 rows. Plus, now you can see that I've just saved my embeddings into this Pinecone index over here. So in any case, if I just reopen this notebook again and I want to use these embeddings which I have saved over here. So what I will do is you can just run this cell over here and you can just comment out this cell. Okay. And you can just run this cell. Okay. So this is how it works. If you just reopen this notebook after a week, so if you want to just access those embeddings, then you can just run this cell and skip this cell. Okay, so now I will just ask first question. So I've just asked YOLO V7 outperforms which model. Okay. So here what we are doing is that we are doing similarity search. So what we are doing over here is that when the user asks a question, we create embeddings for that question, and then we do a similarity search. So I will just try to find top 4 answers for this question from the knowledge base. So over here, I'm doing the same thing. Here we are doing semantic search or similarity search. I am trying to find top 4 answers for this question. So I have defined k is equal to 4. You can define k is equal to 1, 3, 5 as well. So these are the top 4 answers which we have got for this question. One is this, second, third, fourth. So here you can see figure 9 comparison with our object detector, figure 10 comparison with real-time object detectors, precision, IOU threshold. So if I just set k is equal to 3, so I will just get top 3 answers for this question. Now you can see this is the first, this is the second, this is the third. Okay. So what we have done, the user has asked a question. We have done created embeddings for that question. And then we have done a semantic search. We try to find top 4 answers or top 3 answers for that question from our knowledge base. Then we will try to rank those answers, and then we will set the responses to our PaLM2 model, and PaLM2 model will have the question directly as well, and it will generate a natural response. Okay. So here I'm just creating a PaLM2 Google PaLM model wrapper over here. Okay. So now what we are doing is that I've just passed those answers which we have stored over here. You can see over here, we have just passed the answers over here. We have such chain type as stuff, and we have just passed on the PaLM2 model over here. And let's, you can just skip this custom prompts for now. What we can do over here is I will just write YOLO V7 outperforms which model. So now we are using retrieval QA so that we can retrieve answers from our vector database, knowledge database, and using PaLM2 model, which will generate a natural response. So if I just run this now, this is a very quickly generated response. So you can see YOLO V7 outperformed YOLO V4, CSV. And if I just ask Rachel Green qualification, you can say that she is PhD in English and Rachel Green experience. Rachel Green has experience as a graduate teaching assistant. And if you can just run this while loop, and you can do a question answer over here as well. Okay, so if I just write YOLO V7 is used for YOLO V7 is used for object detection, Rachel Green job experience includes Rachel Green experience include being a doctoral assistant at the Department of English. And if I just write exit from here, it will just close it up. Okay, so now you can define your custom prompt over here as well. For more details, you can just go to retrieval QA from chain type, this documentation. You can check the LangChain documentation, and you can just find more details about custom prompt over here. Okay, so I will just give you a quick overview of custom prompt over here. So here you can find, we have find our prompt template, and I'm just writing, use the following pieces of question, a context to answer the question. Please provide a detailed response for each of the question. And where we have that context, the user has provided the question, and I want the answer in Italian. Okay, I don't want the answer in English. I want the answer in Italian language. So I will just run this cell. I'm just creating a prompt template over here. And the input, I have context and question. So I've just defined this over here. Okay. So now what I am doing over here is that I'm just passing the prompt which we have created over here. Okay. And let's ask this question, YOLO V7 outperforms which model? And let's see if we are able to get the answer in Italian or not. So now you can see that I'm just getting the answer in Italian, YOLO V7, Supera I-70 model. So you can see that I'm just getting the answer in Italian. So with the help of custom prompt, we can just getting the answer in Italian as well. So you can just the custom prompt as per your requirements. So that's all from this tutorial. Thank you for watching. See you all in the next part. This video, we will learn how we can create a chatbot to chat with multiple PDF files using the power of LangChain and Google PaLM2 model. Let's look at the demo first, and then we will move towards the architecture, and then we will write down the code as well. So first of all, you can see the Streamlit app over here. So I will just click on browse files. And over here, I will just upload 2 PDF files. Over here, you can upload 3 PDF files or tens of PDF files as well. It will work for all cases as well. So I'm just uploading 2 PDF files. You have the option to upload 3, 5, 10, 20 PDF files because it can deal with multiple PDF files as well. Then I will just click on process. So in the process part, it will extract the data from those PDF files, split the data into small chunks, and then create a knowledge base. So the processing is currently in progress. So this will take around a few seconds, like 10 to 15 seconds more before it gets completed. The processing is done. I have uploaded 2 PDF files. One is the sample resume, an AI-generated resume, and the other is YOLO V7 object detection model official paper. So I will just ask first question, YOLO V7 is used for. The answer of this question lies within this PDF file, YOLO V7 paper. So let's see if our model is able to generate the response from this PDF file or not. So I am as a human, I have asked YOLO V7 is used for. The bot response is object detection. Okay. So YOLO V7 is trained on which data set? So now you can see I'm just asking a second question. YOLO V7 is trained on which data set? So YOLO V7 is trained on which data set? Or YOLO V7 is being trained on the COCO data set. That is correct as well. Okay. So I can ask other question from the resume. Rachel Green qualification. So I'm just asking what is the qualification of Rachel Green. So Rachel Green is PhD in English. You can see also the chat history over here as well. So that's amazing. Rachel Green experience. So Rachel Green has experience in managing editors, poetry staff, editorial assistant, graduate mentor, and composition instructor. And now I can just ask question from the other PDF. YOLO V7 outperforms which models? So this is the other question which I have asked. So YOLO V7 outperforms which models? So this is the bot response. YOLO V7 outperforms the following models. And you can see that the list of the model on which YOLO V7 outperforms. So in this way, you can just upload multiple PDF files in this Streamlit application, and then you can chat with those PDF files as well. So that's look amazing. So let's look at the architecture and let's discuss the architecture of this Streamlit application. So here you can see the architecture of the Streamlit application. So here we are just creating a chatbot to chat with multiple PDF files using the power of Google Palm 2 and then LangChain. Okay, so over here, in the first step number 1, the user will upload the PDF file, which you can see over here. This is the step number 1, the user uploads the PDF file. In the next step number 2, we extract the data from those PDF files. So over here, I'm using Google Palm 2 model. The Google Palm 2 model has an input token limit of 8096 token. So which one token is equal to 4 English characters. So the input character limit of Google Palm 2 model is 32,000 English characters. You cannot pass more than 32,000 English characters at the input of Google Palm 2 model. So when we extract the data from multiple PDF files like 5, 6, 7, 10 PDF files, so as there are a huge number of PDF files, so it can be a case like whether we can have more than 32,000 English characters from the extracted PDF, from when we extract data from the PDF files, we can have more than 32,000 English characters because the user can upload tens of PDF files, and when we extract the data from those PDF files, we can have more than 32,000 English characters at the input. While our Google Palm 2 model can only accept 32,000 English characters at the input, and we can have more than 32,000 English characters at the input. Okay, so as we have extracted data from the multiple PDF files, so we cannot pass that data directly to the Google Palm 2 model. So what we do is we split the data into small number of chunks, and we can say that in each chunk we can have maximum number of 500 English characters. So we split the data into multiple small chunks. Then we'll create embeddings for each of the text chunk. Okay, so embeddings are base vectors. Okay, embeddings are used to compress the size of the text chunk. So embeddings are simply vectors, and embeddings are basically used to compress the size of the text chunk. So if we have 100 text chunk, then we will have 100 embeddings. So we will create embeddings for each of the text chunk, and embeddings are basically vectors, and this is the form of embeddings we have. Like embeddings are basically floating point numbers. You can also say 0.1, 0.3, 0.3. So in this way, we'll create embeddings for each of the text chunk, and then we will combine all those embeddings, and we will build semantic index. And using this semantic index, we will build a knowledge base. So knowledge base is, you can say, vector database where we will store all the embeddings. So after splitting the extracted data into small text chunk and then creating embeddings for each of the text chunk, then we will save all those embeddings into a knowledge base or vector database. So we have different vector databases or vector stores available, which include ChromaDB, FAIS. FAIS stands for Facebook AI Similarity Search. We have ChromaDB as our vector database. So FAIS and ChromaDB are store the embeddings locally. Okay. So we have other vector databases as well, like Pinecone. So Pinecone store the embeddings in the cloud. Okay. So if we store the embeddings in the cloud, it has the advantage that anyone can access it. While here we are using FAIS as our vector database or vector store. So FAIS store the embeddings locally in our system, and ChromaDB also store the embeddings locally in our system. So I'm using FAIS over here. So after saving all those embeddings in our vector database, which is FAIS, so in the next step, when the user asks a question, we create embeddings for that question, and then we do a semantic search or similarity search. In the semantic search, what we do is, for the question that the user have asked, so we have converted that question into the embedding. So we try to find the relevant answers for that question from our knowledge base. So we try to find relevant answer for the question from our knowledge base. And we can say that we try to find the top 5 answers for the question that the user has asked from our knowledge base. And we rank those answers. Like this is the top one. The top answer will be the closest answer to the question that a user have asked. Then we have the second number of, in the second number, we have also the answer, which is the second most closest answer to the question that the user have asked. Then we have a third most closest answer to the question that a user have asked. So in this way, we can rank 4 to 5 results. You can set the K value, like how much results you want from your knowledge base, or how much answers you want from your knowledge base. So we can have 4 different answers. We can have 5 different. We can have only one answer from our knowledge base for the question that the user have asked. Then, for example, we have got 4 different answers for the question from the knowledge base. Then what we do is we pass the user question directly to our Google PaLM 2 model as well. And then we pass the answers, like 4 different answers we get for the question. We have got from our knowledge base to the Google PaLM 2 model as well. And Google PaLM 2 model, what it does is it generates a natural response for the question that user have asked. So we passed all the top 4 answers to the Google PaLM 2 model, and Google PaLM 2 model generates a natural response for the question that the user has asked. So this is the architecture. Let's move towards the code part. Before we go ahead, let me show you how you can get your own Google PaLM API key. So Google PaLM API key is available under Google's Maker Suite. So you just need to go to the website developers.generativeai.google, and then you just need to sign in first. Okay, you can just sign in with your email over here. So if you haven't created your account, you can just create your account over here. So now I will just go to Maker Suite over here. Okay. So you need to request for the access of the API key. So I have already requested for the access of the API key, and I have been granted the access to the API key within 6 to 7 hours. So I will just create an API key. So I have already generated many API keys over here. So I will just copy one of them, and I will be using this API key. Okay, so this is very simple. So let's move towards the code part. So over here, you can see now I have just created a new project in my PyCharm over here. Let me just navigate first. So over here, now you can see that I have created a new project in PyCharm Community Edition. So I think it's visible on your screens. So you can see that I've just created a new project, recording chat multi PDF farm 2. This is the name of the project. You can write any name. So first of all, I will just go over here in the settings, install all the required packages which are required in this project. And I will just go over here, Python interpreter, and I will just go over here and install. I will just install Phi CPU. This is Phi is used as our vector database. And then I will just install LangChain, install package, Google-generative AI, the third package which I have installed. Along with this, I require PDF2 so that we can load the PDF file and extract the data from those PDF files. So I've just installed all these packages. These packages are being getting installed. You can see over here. So this will take few seconds more, then all these packages will be installed. Meanwhile, I'll just write script.py and let's start writing down the code. Okay, so first of all, as we will be creating a Streamlit application, so I will just start over here, import Streamlit. Okay, I have not installed the Streamlit package, so this is a merged package. I will just go to settings. Okay, I will just write Streamlit install. Okay, so this package will be getting installed, and then I will just write import Streamlit as st. Then I will just write from PDF2 import PDF reader. Then from LangChain dot text editor, I will split the text into small chunks. I told you that we cannot pass the extracted data directly to the Google PaLM 2 model because of the input character limit. Or recursive character text letter. Okay, and then I will just import Google dot generative AI info as. We are just importing the Google PaLM model over here. Then I will just basically we'll create embeddings for each of the text chunk, and Google PaLM API comes with its own embedding model as well. So we'll download the embeddings from Google PaLM embedding model. So I will just write from LangChain dot embeddings import Google PaLM embeddings. Okay, and from I will just now import the Google PaLM order. So I will just write from LangChain.lms import Google PaLM. And I will just write from LangChain.vectors towards import files. So files is being our vector database. Then from LangChain.chains, I will import conversational retrieval chain. So we will be using conversation retrieval chain. Conversation retrieval chain comes with a it comes with a memory component as well. So we can keep track of the conversation. So conversation retrieval chain is being built on retrieval QA chain. So conversation retrieval chains comes with a memory component, so we can keep track of our conversation history. Okay, so I will just add a memory component as well. From LangChain.memory import conversation buffer. Yeah. So now what I will just write over here, import OS, and then I will just write OS.environment. Then over here, I will just write my Google API key over here. Google API key, which I would write over here. I already told you how you can generate your own API key. So you can just have your own API key over here. I will just write my own API key. So let me just add that API. So this is my own Google PaLM API key. So first of all, I will just go below down from here and just create a function define main. Okay. So now I will just first write the title of our Streamlit app. For this, I will just write st.page.config. Okay, and the title of our Streamlit app will be chat with multiple PDFs, and the heading of our, so this will be appear in my above the bar, like this will appear chat with multiple PDFs. So let me show you in the, let me just add the header as well, then I'll show you chat with multiple PDFs. And let me add an icon over here as well. We can also write if dash is equal to a. So let's run this. So I will just open this. Okay, currently the package is getting installed, so it will give an error. Let's write further code, and then as this package gets installed, then we'll run it. So first what we want is, we'll just create a sidebar over here with st dot sidebar. So in the sidebar, I will just create item by the name settings over there. And then I will just add a subheader over there as well. Upload your documents. Got your documents over here. And then I will just add pdf.docs st.find-uploader, and I will just write over here, upload your PDF files, and click on the process. Okay, so make it accept multiple files. I will just add accept multiple files is equal to true. And then I will just add a button. So if the user press the and add simply add button. Okay. Okay, so let's run this Streamlit application and see. Oh no, just let's run this Streamlit app and see how does it look for likes for now. So let me just navigate my screen towards it. Currently it's running. Let's see. Okay, so st dot page. So this is the error. Let's sort this out first. So here in here I'm just getting this error. Here we have set dash. So let's see. We just don't need to read on the script, we just need to refresh it. Okay, so now you can see that this is my title, chat with multiple PDFs. So here we have this chat with multiple PDF as our header. Okay, and over here you can see that in the sidebar I have settings, upload my documents. So if the user clicks over here, he can upload multiple PDF files. For example, let's upload some Word PDF files. This is the second, and let's upload the third one. And here the user can click on the process button. Frankly, nothing is happening because we have not added any action for this button. So for now, it looks fine, and as well as it looks good as well. So now let's go ahead further and let's write down the rest of the code. So first of all, what we need to do is we need to extract the data from those PDF files. Okay, so now what I can do is I will just create a function get PDF X. So we just need to extract the data from those PDF files, and just create text over here. Or we'll just go through each of the PDF files, and then we will read the data from them. So I will just write PDF dash reader is equal to PDF reader. So we will just read the data from each of these PDF files, and I will just write for page in PDF dash reader dot pages. Then what we can do, we'll go through each page of the PDF file. Then I will just write page dot extract dash text, extract the text from this PDF files, and this will return as the text. So for now, it's good. So after extracting the data from those PDF files, next what we need to do is we need to split the data into small chunks. So this is our target, to split the data into small number of chunks. So let me show you the architecture again as well. So after extracting the data from those PDF files, we need to split the data into small chunks, and then we need to create embeddings for these text chunks, and then we will create a vector knowledge base or vector database. So next what we can do over here is, so let's first try this. So if the user clicks on the process button, so we will just add st.spinner here. It will just write processing. And then over here, I will just call this. So first we write over here. Okay. So I will just get PDF text and PDF dash docs. And from here, we'll get the raw dash text. So now let's create another function to split the data into small text chunks. So I will just write get text chunks over here, and the input will be the text which we have extracted from the PDF files. So I will just write text dash splitter is equal to recursive character text splitter, and the chunk size will be 1000, and we will have a chunk overlap of 20 characters. So there will be maximum 1000 characters in each of the text chunk, and we will just write text dash splitter dot split dash text, and the input will be the text, and this will return us chunks from here. Now I will just go over here and just call this function below as well. So the input over here will be the raw text which we have got, and over here we will have the output, the text chunks. So that's look good. So next was after splitting the data into small text chunks, we need to create embeddings for each of the text chunks. So I will just write over here, define get vector store. So we will create embeddings for each of the text chunks, and then we will save those embeddings into one knowledge base. So the input will be the text chunks over here, and we will be using Google PaLM embeddings over here. So we will download the embeddings from Google PaLM, and then I will just create a vector store over here. Okay, so the vector store will using files as our vector store, and I will just write from dash text, and the text chunks will be passed as the input. We will create embeddings for each of the text chunks, and this will return vector store. So we are creating embeddings for each of the text chunk, and then we are just creating a knowledge base. So what we are doing is that we are creating embeddings for each of the text chunk, and then we are just building a knowledge base over here. Okay, so good for now. Now we will just create a conversation chain, so that we take the user question, create embeddings for that question, and then we'll just try to find the answer for that question in our knowledge base, and then we'll just rank those answers. So I will just write get conversational chain. Here the input will be the vector. So I will just write Google PaLM model I'm using, and the memory is equal to conversation buffer memory and the memory key will be the chat history over here, and we'll just get the returning messages as well. True. And then we have the conversation chain setup over here, the conversational retrieval chain from dash LM. Input will be the PaLM model, and the retriever will be the vector stored as retriever. Okay, and here we have the memory. Okay, so that's the word, and then this will return us the conversation. This return us the conversation chain. Okay, so conversation retrieval chain is built on retrieval QA chain, but it provides a memory component as well. So which was missing in the retrieval QA chain. Okay, so I will just call this. Okay, I have not called this as well. So what I will do is get vector store, and the input will be the text chunks over here. And from here, I will just get the vector store, and then I will just call the at conversation chain, and here will be the vector store over here. And over here, I will just get. So I will just create a session state over here. So in any case, so our information is not lost. So st.state conversation is equal to conversation chain. So that's the good for now. After all this processing is done, then we will have that st.success. So we will have that done text appearing after all this is being done. So now what we can have this. So when the user asks a question, then what we can do over here is, but before going ahead, let's run this and see if it works fine or if there is any error. So for now, let's check this out. Yes, let's run this up for now. So let's upload the PDF file. Let's upload only one PDF file to check if it works fine or is there any error. Wow, I think there is an issue. And let's see that. So there is an error. So let's see first. So there was an error over here as well. Got it. So other error which we are getting is so these spellings are not right. So let's run this again now. So there is another error. So let's run this again. So let's upload a PDF file over here. So it's processing, and let's see if it is done or if there is an error. So now it's done. It means that currently it's working fine. So let's complete the rest of our code. So here, let's add the option that user can ask a question. Here the user can input the question, user-question, st.text-input. Okay. Ask a question. Okay. So next, what we can do is, so if the user asks a question, that question currently let's write pass here. So what if the user asks a question? So what we can do is just create another function. define user input. If the user asks a question, the user question input. So if the user asks a question, then the response will be a state.session state. So conversation. The question. Then what we can do is I will just write conversation. So from here, what we write over here is st dot. So we can just create another session state over here. State share history. So we will only take the chat history component from here. So what we can write over here is okay. So now what I can do is in an upgrade. So we'll want to get the index position as well. So I will just write sp dot session state dot chat history. Okay, and I will just write over here. So st dot write I. Okay, so let's run this up and see how does it work. Okay. So one error which you can avoid is what we can do. Okay, let's call this user input and just pass user question over here. And what we can write over here is yes, conversation not in st or session that's there. That is not in st dot session that's there. Okay, so that's the word. Let's copy this any case to avoid. So let's run this up now and see if it works fine or if there is an error. So we can fix it. Currently, we'll just look with one PDF file and later we will just go with multiple. Okay, and I will just ask a question, region, qualification. So let's see what we get from here. Okay, so now you can see I've just asked Rachel qualification and Rachel Green has a PhD in English. Okay, PhD from University of Learners at Urbana-Champaign. So experience. So here we have Rachel Green experience. Okay, that's the word. Rachel Green. This. So now you can see that we can track previous conversation chat history as well. So that's good. Yes, this is Rachel Green resume as well. So what we can do one thing further is just comment this out here. Just remove this. 0. Then we can just write st.write. Over here, this will be the one message. So here we will not get any reminder. So if you just see this over here, on 0, on even numbers, we have the question, and on odd numbers, we always get the response. Okay. So in our numbers like 0, 2, 4, we have the question. And on odd numbers, we have the results response. Okay. So what we can do for this is, message 10. That's on odd number, we have the bot response. So we can just, okay, let's run this again. So let's upload multiple PDF files. Now let's just first upload one PDF file and see if it's working fine. So this is my human Rachel Green calculation, and here I'm just getting one PhD in English. Okay, let's look. Okay, so let's start with multiple PDFs from here. So now I will just upload multiple PDF files from my system. Let's upload this. So I will just go with these two PDF files, and let's click on process from here. So this might take few seconds more. The processing is being done. You can see the message, and let's ask here the V7 is used for. This is the first question which I am asking. YOLO V7 is used for object detection. Okay, YOLO V7 is trained on. I'm just asking YOLO V7 is trained on which data set. YOLO V7 is trained on the COCO data set. Okay, Rachel Green Education. See another question which I am asking. What is Rachel Green Education? Rachel Green went to Butler University MBA in English and Communication. Okay, Rachel Green qualification, PhD in English. Okay, Rachel Green experience. Okay, so here's experience coming. All this YOLO V7 outperforms which YOLO V7 perform all known object detectors in both accuracy and speed. So here you can see that we have created a chatbot to chat with multiple PDF files using the power of LangChain and Google PaLM 2 model. So that's all from this tutorial. Thank you for watching.